So hello everyone, I'm Sanskar. So today we are going to learn about minimization of DFA. And before learning about minimization of DFA, we have to learn what is DFA. So there are two types of finite automata. One is deterministic finite automata, and the other one is non-deterministic finite automata. So how would you differentiate it? So one of the difference would be that dead state is not allowed in deterministic finite automata, which is DFA, and in NFA it's allowed. So how would we take it as, like, for example, I take Q1, Q0 as the starting state and I apply 0 to it. It goes to another state Q1. So for example, it contains symbols 0 and 1. So here uh, we didn't apply 1 to any state. So therefore it becomes a dead state, which is not allowed in DFA. So we have to make a loop or something with symbol 1. So if I take here it as here, so now this becomes a DFA. So for NFA, this thing is dead state is allowed. So for example, if I remove 1 from here, it is still it's an NFA, so it is allowed. So here, what is DFA? DFA refers to the deterministic finite automata. Deterministic refers to the uniqueness of the computation. The finite automata are called deterministic finite automata. If the machine is read an input string once, it's one symbol at a time. In DFA, there is only one path for specific input from current state to the next state. So here you can see U0 is going to another state of Q1, and Q1 is the final state. So the DFA can contain multiple final states. It is used in lexical analysis and compiler. So is just a simple example for DFA. So what are the formal definition of DFA? A DFA can be represented by a 5-tuple Q, sigma, lambda, Q0 and F. So Q0 is a finite set of states. So Q0, Q1, Q3, these are all the finite set of states. And this is alphabet. Sigma is called alphabets. Actually, these are like set of symbols 0, 1, 2, or A, B, C, anything. And lambda is the transition function. And Q0 is the initial state. So in the previous slide, if you see, so we've seen earlier, this is the initial state. There'll be one arrow on it. So this is what you call the initial state. Then F is the final state. We have seen it earlier. It's made by two circles like this. So this is the final state. So what is now we are going to learn about the minimization of DFA. In automata, DFA minimization is the task of transforming a given deterministic finite automation into an equivalent DFA that has minimum number of states. Here two DFAs are called equivalent DFA if they recognize the same regular length. Several different algorithms accomplishing these tasks are known and described in standard textbook and automata theory. Unreachable states are the states that are not reachable from initial state of the DFA for any input string. These state can be removed. The dead states are the states which we have learned it earlier. So what are dead states? Which has no final state which is reachable. These states can be removed unless the automation is required to be complete. Non-distinguishable states are those states which cannot be distinguished from any other input string. These can be merged. So let's do a problem. So here you can see that from Q3 1 is applied and it goes to, so here you can see the Q4, Q1, Q2 are the final states, and Q0, Q3 and Q5 are the non-final states, and Q0 is the final state. You can see here is the arrow, you can see. So Q0 is the Q0 is the initial state. So we have made the transition table from the previous diagram. So from Q1 0 is applied, symbol 0 is applied, and it goes to Q3 state. If 1 is applied, it goes to Q1 state. So same for every states. So here you can see the asterisk, it is actually the final states, and these are the non-final states. So first, let's see, the P0 will have two sets of states. One set will contain Q1, Q2, Q4, which are the final states. So here we have marked them. So these are the final states. These are the final states, and the other set will be Q0, Q3, Q5, which are the non-final states. So this is how they are made. Like, so P0 will look like this. So to calculate P1 now, P1 we have to check whether sets of partition of P0 can, if set of partition P0 can be partitioned or not. So first we have to take Q0, Q4 and Q2. Q1, Q2 and Q4, sorry. So if you see here in Q0, if you compare these, so here you can see that all lie in the same, all are same. So Q2 and Q2 all are same. Even in 1 it's the same. So therefore this set is non-distinguishable. It stays as Q1, Q2, Q4 itself. So now let's go for the non-final states, which are Q0, Q0, Q3 and Q5. So for set Q0, Q3, Q5, moves of Q0 and Q5 on input symbol 1 are Q1 and Q5 respectively. So here you can see Q0 and Q5. If you see them, the moves on input symbol 1. So 1, they are Q5 and Q1. So here you can see that it's different. So Q1 is in one set and Q5 is in another set. So therefore these two will get partitioned, and if you see for Q3 and Q5, they are not distinguishable. So therefore this is how they look. You can see here, this is how they look, P1. So Q5 has been partitioned from Q0 and Q3. So next, if we go, so from earlier we have seen, so now for set Q1, Q2 and Q4, we are doing this for the set of P1. So it stays as Q1, Q2, Q4 as it is, because here you can see that Q2 all for Q4, Q1 and Q2, and even for symbol 1 it's Q5. Now for set Q0, Q3, so here also it's the same. So for set Q0 and Q3, if you see 0 is applied and it goes to Q3 and Q0. So it's the same, it stays as it is, and even for 1, Q1 and Q4, which lies in the same. Here you can see Q1 and Q4 they lie in the same set. Then after, and if we go for Q5, which can't be partitioned further because it's only one symbol, one alphabet I mean. So for now we get P2. P2 is this. So you can see this is the one which is actually equal to P1. So we get P1 and P2. So next. So this is how it looked earlier. Now it looks like this. So from P2 we can see that first set is Q1, Q2 and Q4, which are the final states. So therefore we have merged them into one, and this is the final state. And we see here Q1. So Q1, Q2 and Q4. So zeros applied. So it's a DFA, right? So there can't be dead states. So therefore we have applied zeros and ones here. And Q5 has a self loop because it doesn't go anywhere. So here you can see, and Q0 and Q3 are merged together. Here you can see. Then Q5 here. And this is how it looked earlier. And this is the minimized DFA for this diagram. So that is all for today. Thank you.